Number 13, a hand-driven tire pump has a piston with a 2.5 centimeter diameter and a maximum stroke of 30 centimeters. Letter A, how much work do you do in one stroke if the average gauge pressure is 2.4 times 10 to the 5 newtons per meter square? All right, so basically we have to relate pressure, volume, and work. We have that formula over there. It says that the net work done is going to be equal to the gauge pressure multiplied by the change in volume. Okay? And they tell us the gauge pressure, right? It's 2.4 times 10 to the 5th, so that's great. And they tell us the maximum stroke. What that means basically is that, you know, if I call this, let's just say, it doesn't really matter. If I call this the initial position, right, and then this, it would be the, as it gets pumped down, right, like a bike pump, okay? That's the final position. Then the stroke length is essentially the height here of the cylinder that got, that's volume was compressed. Hopefully that kind of makes sense. So this is basically delta H, and that's going to be about 0.3 meters. Okay. It also tells us then the diameter of this piston here. It tells us the diameter, but you know we don't want the diameter, we want the radius. So we have to basically take the diameter that was given of 2.5 centimeters, but remember we need it in meters, so 0.025 would be that in meters, and then divide that now by 2, okay, and that would be the radius. So essentially now I have everything I need in order to calculate now the net work, okay? So here the net work, so let's plug this in. So the net work here will be equal to the gauge pressure, so 2.4 times 10 to the 5th, all right, multiplied now by the change in volume. So that change in volume you can rewrite as pi r squared times delta H. Remember, the volume of a cylinder, which this is pi r squared H. And what's happening is that the volume is changing over time because the height is changing over time. So that's how I can make that relationship. All right. And now basically, I know I plugged in the number over here. I probably should have waited for that. But now I'll plug in all the values, okay? So the net work is going to be 2.4 times 10 to the 5th, then multiplied now by pi r squared. So what's the radius? So this is going to be, actually, let me just calculate it. So that should be we could do that in our head, right? 0.0125, all right? And that's squared. And then multiplied by the change in height, okay? Now the change in height, this is kind of, you know, in terms of the signage, I would think about what do I need to calculate, and then I kind of would work out the sign. I would work out the sign appropriately, all right? If it says, how much work do you do? All right, they're not really asking me for a sign, more or less. We can just take the absolute value. It's okay. The way I organize this initial and final, this height would have been negative. And that would kind of make sense because in order for me to compress this piston, I would have to expend work, right? My work should be negative. So that being the case, I'm going to just plug in the negative 0.3 here, okay? Because the distance is negative if initial is higher than final, right? You're going down. So the net work here will then be a negative value, but I wouldn't get too sidetracked with that. I mean, the magnitude is, they want to know how much work do you do. You can just give the magnitude. All right, the sign really is not important here for this problem in terms of the answer. Times then pi multiplied by 0.0125 squared multiplied by negative 0.3. And I get a negative 35.3 or so. So there's about negative 35.3 joules. But again, you could leave that as your answer, it doesn't matter, or you can just give the magnitude, so of about 35.3 joules. All right, and that should suffice. And now let's take a look at letter B, right? So letter B says, what average force do you exert on the piston, neglecting friction and gravitational forces? All right, so basically we have to realize that we're trying to connect force and work together, okay? So the way that they're connected is via this formula. Blast from the past, work is equal to force multiplied by distance. Now in this particular case, in order for me to find the force, right, I can simply just divide out the distance from both sides, all right? So essentially, the work we just found, right, we found that that's 35.3 joules, and then divided by now the distance, right, over what? What does that exactly mean by distance? Well, the distance now is going to be the distance of compression, right? How much did you compress it? Okay? So how much did you compress this thing? Well, you compressed it by 0.3 meters. All right. So that is the distance that we're going to plug in, 0.3. And all now we simply need to do is just plug that into the calculator. So this is going to be about 35 point blah, 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 divided by 0.3. So this is about 118-ish. All right. So it's about 118 newtons. All right. And that should then take care of that. So that's actually fairly straightforward. Guys, thanks for tuning in. Appreciate it very much. Please remember to help us out and subscribe, and we'll see you next time. Take care.